Alrighty guys, here's the last question on packet 6-7. Okay, it's a classic example of Ferris wheel. Okay, it's telling you that the height you are above the ground varies sinusoidally, and it probably should say with time. Okay, so that just means it creates a sine or a cosine function. Okay, so it says consider the height of the center of the wheel to be the equilibrium point, the point that does not change. Okay, so it's like the middle. This wheel has a diameter of 40 feet and travels at a rate of 6 revolutions, or 6 times around per minute. When you get on the ride, your seat is 5 feet from the ground. Okay, so if they're talking about revolutions, right, that's how many times it goes around the circle, okay, in 1 minute. So we usually want to graph one full turn around this, right? Like we did in our previous examples. So if it's 6 revolutions per minute, well, that means that one revolution, if we think about this in seconds, 60 seconds divided by 6 gives us 10 seconds. So I know it seems a little ridiculous, but apparently this Ferris wheel goes around in 10 seconds. Okay, so it's very speedy. This wheel has a diameter of 40 feet. So, and you start, right, when you get on at 5 feet from the ground. Okay, so what this is gonna look like is, we're gonna have a graph here, okay? You are gonna get on at 0 time, right? When it starts its rotation, okay? And then, sorry about that. So this is our seconds, right? We want to label our axes. Some of you are not labeling your axes. Make sure you do that, okay? So 0 seconds. And it finishes a revolution in 10 seconds, okay? And we get on, right? That revolution starts at 5 feet because that's when we get on. Now, if I start here, the maximum, that height that I will reach, well, this is 40 feet in diameter. So the tallest point, right, I will get around at the top of this, in the middle of the cycle, I will reach 45 feet because there's a diameter, right? Your diameter is 40 feet, right? So this is feet. So if my diameter is 40 feet, I start at 5 feet because that's when I get on. And then I reach a maximum of 45 feet at the top, right, when you can see the whole park. And then I come back down, right, a full revolution in 10 seconds, and I reach my lowest point where I got on at 5. So this will look like that, okay? So this will be a cosine curve. On your homework, some of you are not turning here. This is your minimum point, isn't it, right? So you should not go below this, okay? Make sure you turn back around because then you start going up again, don't you? And then back down, right? So that's your height, okay? So again, this is feet. This is our height. Let me put that in there, okay? And this is seconds or time, right? And at our midpoint, we can put 5. Again, I've said this before, but you don't have to put all 5 critical points. You really just need the mins and maxes, but you can put it in if you want. So to write our equation, right, we have our 5 and our 45. That has a difference of 40, which means my midline has to be 20, right? Have 20 above and 20 below. So that means my midline is right in the middle here at a height of 25. Right, so that means D is 25. And then if I think about this as my upper boundary, right, my A value will be 20 because that's the amplitude, the distance from the midline to the max or the midline to the min. Okay, so that's my A value. Then if I take a look at this, this has to be a cosine curve, right, because it doesn't start at the midline. Okay, it starts down below, which means I have a reflection. So it's going to be y equals negative, right? My A value we said was 20, cosine, okay? I'll find out my B in just a second, okay? x or theta, however you want to do it, but I'm doing this in terms of x because we're on an axis. So x minus, there's no shift here, so it's just x. And then my d value is plus 25, okay? So what's my b value? Well, remember b is always your period, right? Divided by b equals your new period. So my period from beginning to the max to the back down to the min is 10 seconds, right? So if I cross multiply, I get 10b. So therefore, divide by 10. So I think I get pi over 5 equals b. So that is my equation. Now technically, I just asked you to write the equation, so you don't need this much detail in your graph. It's just really kind of there to help you. But I think it is helpful. Okay. So then we go on to the next part, right? Which is find the height after 22 seconds. Okay. So this part on the homework, and I've looked at you guys' first sinusoidal graphing homework, and this type of question you guys had no trouble with. So this is just, if I'm giving you 22 seconds, then I'm just giving you time, right? So if I move this up, let's move that up. Okay, can you guys see that okay? All right, so now let's do the second part here. So you guys were able to see that x is really my time, right? Because that's my x-axis, so I'm just saying x is 22. All right, so then I'm gonna plug in y equals negative 20 cosine, this should say pi over 5. Okay, I wrote that wrong. Okay, so pi over 5. X. And since there's no shift, you can just put one set of parentheses there. Okay. And then plus 25. So then we would go to our calculator, right? Second quit. Make sure, again, your mode is radians. And then we're just going to put in negative 20 cosine. And then on the calculator, I always put my, oh, this should be 22. So times 22. Okay. So then I'll do times 22. And plus 25. And that should be my height. Okay, so round to the nearest tenth. So at 18.8 feet, that will be my height at 22 seconds, okay? So you can also do that on the graphing calculator if you go and you graph it, just so you know, because we're gonna have to graph it anyway for this part. So if I put this in, so negative 20, right, cosine, second pi divided by 5 times x plus 25, and I put that in my calculator, okay? And I change my window, so you always have to change your window, so I should go 0 to, let's say, 15, so I'll keep it at negative 2. Then maybe go to 15-ish, a little bit more than 10, or 12. Let's say 12. Then don't really need negatives here, okay, for my y value, but maybe I just want to make it 0 at this point because my graph really starts at 5, and then my maximum height here I can see is 45, so let's maybe make that 50. So if I hit graph, I should see my cosine curve. And then if you don't want to do this, you can just do second, trace, and do value, and do 22. And the problem it's going to give you is the graph isn't long enough, so you can't see 22. So then if you want, you just have to make your x max have enough so that you can see 22. So if I make it 25 and then go back to my graph, you see more of the curve, right? But it's sinusoidal, so it continues. And then I go to second calc value, 22, and there's our answer, okay? So after 1, 2, on the third revolution is when 22 seconds is there? Okay, so you could do that also, just so you know. I'm gonna go back to my window and make it more fitting of what we have there, okay? So this is again gonna be 12. So there's my curve. It should look like what we have there, okay? So I want to see, this is what we had trouble on the homework. The first 2 times this particular seat will be 27 feet above the ground. So what you're trying to do there is, if this is your sketch, right, and it looks like this, you're trying to see when does it hit 27 feet. What are the first 2 times? Okay, that's what I asked you guys. So what we're gonna do is we're gonna see when your curve intersects y equals 27, because you can't use the value function like we did, because this is the y value, okay? Because we're trying to find time, right? So you've given the height, not the time like we were in the previous example. So now we're going to go to y equals, right? Put 27 in. Then calculate the intersection point, which we will see here. So there's 2. Hit enter 3 times, and we get, at 27, our height is 2.659, and I say round to the nearest 10th, so let's carry it out 3 places. Okay, so your work, it would just be 2.659, comma 27, and then our next intersection point, right, for the first 2 times, would be hit enter 3 times, and we get 7.340, right, comma 27. So then we want to find the difference of those 2, and that's how much time you will be above 27. So you hit 27 feet at 2.6 seconds, and you then again hit it at 7.3-ish. So if I find the difference of those 2, minus 2.659, that's 4.7 about seconds, okay? So that would be the difference of the 2, okay? Right now I'm just asking the first 2 times, okay? So if I ask you how long, right, you would do the difference. So how long, right, would be this number, right? So 4.7 seconds. That's how long you're above there. Here I'm just asking for the 2 times, so that would be like 2.7 at 2.7 seconds and 7.3 seconds. The only other thing I would ask you, right, is not how long, but what % of the time are you at 27 feet or above? And that's when you would just take 4.7, so to get the %, you would divide by what a full, right, because this is just a sinusoidal function, so it's going to continue this shape. So each time, a full revolution is 10 seconds. So if I take 4.7, right, divided by 10, that gives me about 47% of the time you are at 27 feet or above, okay? So that's the only other question. So I may ask you, what are the first 2 times? I may ask you how long, right? And then you would find the difference. Or I might ask you what % of the time, and that's when you're gonna divide by a full cycle, okay? So that's number 5. Your homework is to finish the rest. I will post the answer key as well as my notes. And I hope you are all doing well, all right?